Hi students, and welcome to today's lesson. I'm Mr. Hunter. Today we will explore the question, how does the moon appear to move across the sky? Are you ready? Grab your pencil and your science journal, and let's get started. Hey, when was the last time you looked up at the sky and saw a full moon? Look at these cards. Each card shows a full moon at different times during the same night. We will observe all 4 cards, then arrange them in the correct order. What clues can we use to determine the correct order? Well, I see trees in 3 of the photographs, so that must be the horizon. Maybe the moon is rising in the sky. Let's put the cards side by side. Okay, now all the moon cards are lined up in a row, but are they in the correct order? How can you tell? Now that I look more closely, I think this card should be at the very end. Do you agree? Let's try again with this card at the end. Okay, now are the cards in the correct order? I think this order makes sense. What do you notice about the apparent motion of the moon? Maybe you notice that the moon looks like it's behind the trees in these photographs, but the last photograph doesn't show any trees. I noticed that too. What direction does the moon appear to move? With the cards in this order, the moon appears to move up into the sky, right? And it looks like a complete circle. Those are great observations. What do you wonder about the apparent motion of the moon? I wonder, where will the moon continue to move in the sky? Do you wonder the same thing? Maybe you wonder, how does the moon move across the sky? Those are excellent questions. In today's lesson, we will explore a very similar question. How does the moon appear to move across the sky? But how can we explore this question? I know, we can create a model. Let's create a space view model with the same materials we used in the previous lesson: a lantern, a mini globe, craft sticks, and foam discs. And this time we'll add a mini moon. Let's use these materials to show where the moon must be for it to be visible from Earth at night. So here we have our model set up with the lantern, mini globe, and mini moon. What do you notice? Do you notice that for this side of Earth, it's daytime? And for this side of Earth, it's nighttime? And the moon is on the opposite side of the Earth from the sun. For us to see the moon at night, it must be on the side of Earth experiencing nighttime, the opposite side of Earth from the sun. Let's draw a sketch of our model to show what we observe. Here's our light source, which represents the sun. And here is Earth. This side of Earth is experiencing daytime. And this side of Earth is experiencing nighttime. Nice work. Where should the moon be? Should it be between Earth and the sun? Or should it be on the other side of Earth? Well, if we see the moon at night, the moon must be here, right? Let's add an explanation to our model. The moon is on the night side of Earth, which is the side of Earth opposite from the sun. Before we continue to explore the moon's apparent motion, let's review what we know about Earth and the sun. How do components of the Earth-Sun system interact? Maybe you were thinking the sun provides light to Earth. As Earth rotates, daytime and nighttime happen. That is a great observation. In other lessons, we observed that sunlight causes shadows on Earth that change as Earth rotates. We also noticed that the sun appears to move across the sky because of Earth's rotation. But we haven't explained how the moon appears to move across the sky, have we? What additional information could we gather to help us determine the apparent motion of the moon across the sky? I know, we could look at a video clip that shows the moon's motion. Let's watch the video clip together. Both the sun and the moon will be visible, so pay close attention to their apparent motion at different times of day. Are you ready? The video clip starts during the daytime, but then nighttime quickly arrives. Oh, there's the moon. Do you see it? It appeared to rise in the nighttime sky. And now it's daytime again. And look, the sun appears to rise in the sky. The path of the sun and the moon are similar, aren't they? Do you think the sun and the moon appear to move in the same direction across the sky? I think so. Let's watch the video clip one more time. What do you observe about the moon and the sun in the video clip? Do you see any shadows that could give us clues? Maybe you observed that we saw the moon rising like the sun rises, although they do not follow the exact same path in the sky. Do you agree? If so, you're right. Does the video clip support your explanations about the apparent motion of the moon? Why or why not? Perhaps you're thinking, the video clip supports that the moon also moves east to west across the sky because the moon is moving in the same direction as the sun. I agree. Nice work. Let's revise our Earth View student model to incorporate the moon. Does this photograph represent the nighttime view from Earth or the daytime view from Earth? How can you tell? Well, we know from our model that for the moon to be visible from Earth at nighttime, the moon must be on the opposite side of Earth from the sun. So, the Earth View student model in this position, where the Earth student faces the moon student, represents the nighttime view from Earth. Can we use this Earth View student model with the moon to model times of day? I see times on the model already. 12 noon, 6 p.m., and 12 midnight. How do you think the times were determined? Maybe you're thinking, solar noon is when the sun is highest in the sky, so that must be why 12 noon is marked facing the sun. If so, that is correct. What about at 12 midnight? The Earth student would face away from the sun at midnight, right? 12 midnight must be on the nighttime side of Earth, opposite 12 noon. How could we use this clock to model what the Earth student sees in the sky at different times of day? Maybe you're thinking, the Earth student can rotate to model different times of day. We can determine whether she can see the moon in the sky at each time. That's a great idea. Let's try it. Let's see. Where is 9 p.m. on the clock? Well, 6 p.m. is here, and 12 midnight is here. So 9 p.m. must be halfway between. Do you agree? Okay, great. Let's have the Earth student rotate to 9 p.m. Imagine you are the Earth student. What would you see from Earth at 9 p.m.? Our student can see the moon, but can she see the sun? No, she can't. It's nighttime, and the moon is visible. Great work. How can we model the apparent motion of the moon through the sky at night? What if we have the Earth student start in a nighttime position and face the moon? The moon student will stand still, and the Earth student will rotate counterclockwise. Imagine you are the Earth student. If you were the Earth student, how would the moon appear to move in the sky as you rotated? Let's watch as the Earth student rotates. Look closely. The moon would appear on her left side, which is east, and disappear on her right side, which is west. So the moon appears to rise over the eastern horizon and set over the western horizon, just like the sun. Because of Earth's rotation, the moon appears to move from east to west, just like the sun does. How interesting. One of your tasks after this lesson is to explain how we modeled the apparent motion of the moon through the sky at night. Did you know that the moon rises and sets just like the sun? Moonrise occurs when the moon appears over the eastern horizon. Look at this photograph of a moonrise. The moon is appearing over the eastern horizon. Moonset occurs when the moon disappears over the western horizon. Let's watch a video clip of a moonset. Are you ready? Here we go. Wow! Did you see the moon disappear over the western horizon? That was amazing! Your second task after today's lesson is to summarize what you learned about the moon. Let's revisit our driving question board. Does our new knowledge help us answer some of our questions? Which questions are still unanswered? I don't think we addressed these questions. Why can we sometimes see the moon during the daytime? Or, why does the moon's shape change? Those are interesting questions. In upcoming lessons, we will begin to explore the question, why is the moon visible at different times of day? We learned so much about the moon today. I wonder what the moon will look like in the sky tonight. Maybe it will rise in the sky like we saw in these photographs. Wouldn't that be amazing to see? I'm so excited to find out more about the moon with you. Let's review your tasks for today. First, answer the question about the apparent motion of the moon. Second, summarize what you learned about the moon in this lesson.